Okay, this is Mr. Collins here. We're going to look at sums of infinite series. This video coincides with a handout that you can download from Schoology. And this is actually the end of chapter 13 of your textbook. Not that we really break out a textbook, but online we have all the handouts from the textbook, so let's put it that way. So I thought I'd start with a warm-up, which says find the sum of this series. Now, if you look at it, it's an exponential function. It's 2/3 to a power, and remember, those are geometric. And right now, the sum of a geometric series is given by that formula to the right. So if you look at this, if I plug in n equals 1, the first term is 1 million. So that's my a sub 1. Okay, my n is the number of terms, and if you look at the indexing variable, it goes from 1 to 20, so it looks like there are 20 terms. And actually, I'm picking up a typo. We have n in the formula, and the indexing variable is a k. That makes no sense. So guess what? Take that k and make it an n. You just got to be consistent, just like that. You can't have two different variables in these. Make no sense. And finally, the common ratio is the base of this exponential. It's 2/3. In other words, every time you go one step further in the sequence, you keep multiplying by 2/3. So the first term would be 1 million. Second term would be 2/3 of 1 million, which is what's 666,666. And the next term would be 2/3 of that. And each term gets smaller and smaller and smaller. And of course, what are we trying to do? Add up the first 20 of those. Again, you could get all 20 of those numbers and add them up, or you could do this the smart way and use the formula that we have right here given on the page. And so it's the 20th partial sum. That's what that S sub n means. It means add up the first 20 terms. The first term is 1 million. 1 minus the common ratio here is 2/3, and that gets raised to the 20th power. N is inside the parentheses, so it's 2/3 to the 20th, and that gets all divided by 1 minus 2/3. So you got to really carefully put this in your calculator. And again, make sure that 20th power, that's not out, that's inside the parentheses. And if you're careful about this, you could calculate it. This is going to be just under 3 million. And in fact, pardon me, I had this written out and I can't find the paper, but it's 1 million. It's 1 minus 2/3, which is jacked up to the 20th power, and then divided by 1 minus 2/3. So really you're dividing by 1/3. So be careful with your parentheses. And I get a number just under 3 million. It's 2,999,999.998. And guess what? That's the first 20 terms. And kind of what we're getting at now is if you do this forever, if you keep adding up an infinite number of terms, you're actually going to hit 3 million. And you're thinking, well, why, when you go from the 21st term to an infinite number of terms, do you not go up by much? Because you keep multiplying each term by 2/3, which lessens it. So you're kind of, after the 20th term, you're really not adding much at all. That's going to be the upshot of today's lesson. We're going to look at infinite series that go on forever. And I think in this example, we'll just look at the first example here. It says, look at the partial sums. So before I look at the sums, I'm going to look at the sequence, not the series, but just the sequence, which means plug in 1, plug in 2, plug in 3. If I plug in 1, I'm going to get 1 over 1 times 2, which is a half. If I plug in 2, I'm going to get, on the bottom, I'll have 2 times 3, which is 6, so I'll have 1/6. If I plug in 3, on the bottom will be 3 times 4 will be 12. If I plug in 4, 4 fives are 20. And if I plug in 5, 5 times 6 is 30. And you can see that this sequence converges to 0. It becomes pretty evident that the limit of that infinite sequence is 0. Now I want to look at the series. Now the series is, hey, what happens when I add these up? So if I add up the first term, it's a half. If I add up the first 2 terms, it's 1/2 times, 1/2 plus 1/6, which is 4/6, which would be 2/3. Okay. If I add up the first 3 terms, 1/2 plus 1/6 plus 1/12, I'm going to get 3/4. And if I take that and I tack on 1/20th, so if I add up the first 4 terms, I'm going to get 4/5. And I think already you're seeing a pattern. The next one here is 5/6, and so on and so forth. It's really just n over n plus 1, or k over k plus 1, however you're indexing your series. And this should be obvious, 5/6, 6/7, 7/8, 8/9, 9/10. And you could even look at it as a decimal if you like. Either way, this is getting closer to 1. So when they say, hey, what's the sum, that infinite sum? It's actually 1. The answer here is 1. Okay, we're going to have a couple more videos to finish out, to finish this out.